Okay, welcome back. Welcome back. Thank you. Thank you for your maximum cooperation. So, what we're discussing now is relations between the ratios. We've proved that sin theta divided by cos theta will give us tan theta. So they are all the relations. We have the first one, sin theta divided by cos theta is equals to tan theta. We have proved this. The second one, we still have that sin square theta plus sin square theta, okay, plus cos square theta. Cos square theta is equals to 1. So we are going to prove this one quickly. So how do we prove that sin square theta plus cos square theta is equals to 1? We still prove it by drawing a diagram, an illustration of a right angled triangle. So, a right angled triangle, we have something like this. This is a sign of right angle. This is sign of angle theta. We have A, we have B, we have C. Okay, at this point now, see what we're going to do. So this side, we are going to name here small letter B, small letter C, small letter A. So remember, from SOHCAHTOA, know that you have to note that sine is opposite over hypotenuse, and this is opposite, and here is hypotenuse. So cos is adjacent over hypotenuse. So and tan is opposite over adjacent. Okay, from here we'll now be having that sin theta. This theta now is equals to opposite, which is C, divided by B. So we are considering sine and cos. Cos theta is now equals to, from SOHCAHTOA, adjacent is A, divided by SOHCAHTOA, hypotenuse is what? B. Okay, let's now prove from here that sin square theta plus cos square theta is equals to 1. Okay, see what we're going to do. Sin square theta is going to be C divided by B, all square. So plus cos square theta is A divided by B, all square. So we open bracket, this will be C square divided by B square plus A square divided by B square. So at this point, the LCM is B square. B square. So that means B square can divide B square. So we now have the LCM as B square divided by B square divided B square to give us 1. 1 times C square will give us C square plus B square will divide this one to give us A square. So at this point, you have to recall from Pythagoras rule, which states that hypotenuse square is equals to opposite square plus adjacent square. Okay, relating to this diagram now, hypotenuse is B, which is B square is equals to, opposite is what? C square. We have C square plus adjacent is what? A square. So if B square is equals to this, we can substitute. Anywhere we see C plus A, which is C plus A, we substitute with B square. So we can now have that this C square plus A square divided by B square is now equals to, because this is the same thing as this, we can use B. This will now give us B square divided by B square, which will give us 1, because B square will cancel B square to give us 1. So that is, we have proved that sin square theta plus cos square theta will give us 1. Okay, so that is for that. We'll be going to complementary angles. We have complementary and supplementary angles. Two angles are said to be complementary if their sum gives you 90 degree, and they said to be supplementary if their sum gives you 180 degree. Okay, let's take a look at this now. Let's take a look at this. Have complementary so we'll only be talking about complementary. Yeah? So in a triangle, in the diagram, below, we'll be having that C, the angle at C is 90 degree, and A is equal to theta, while B will now be 90 minus theta. Okay, let's now angle A and B are complementary. Okay, let's now take a look at the illustration. We have this, a right angle triangle. We have this as well. Okay, this place is B, this place is C, here is A, here is theta, here is the sign of right angle, and this place will now be 90 minus theta. That means A and B are said to be complementary. So that because two angles are said to be complementary, if their sum gives you 90 degree, that is, if you add them up, they will give you 90 degree. Okay, let's okay. So at this point now, this complementary angle, so this will be used in trigonometry, in calculations in trigonometry. Let's take for instance now, if relating this to trigonometry, we have that sine theta is equals to cos 90 minus theta. Let's take for instance now, if the value of theta is 2, that means cos theta will now be 90 minus 2, will give you the value. Okay, so and sin theta is this. Okay, and cos theta is equals to sine 90 minus theta. So we can use this thing to solve questions, more questions. Okay, from there, let's solve these examples. We have solve the equations. Okay, we have the first one, A, sine theta is equals to cos 35 degree. B, sine alpha is equals to cos 3 alpha. C, cos 2 theta is equal to sine 3 theta. D, cos x is equal to sine bracket x plus 22 degree. So I'm going to solve like 3. So at this point, we're now going to have, let's do that here. Okay, the first one, A, sine theta is equals to cos 35 degree. Recall that sine theta is equals to cos 90 minus theta, and cos theta is equals to sine 90 minus theta. So we can simply use this. So you have to make one to be the same. Like the first one now, we have sin theta is equals to cos 90, cos 30, 35. So simply what we are going to do now is so we'll now say that if sin theta is equals to cos 90 minus this, cos 90 minus this, so we now have that if sin theta is this, so we have to make all of them to be in uniform, so that if it's cos can cancel cos. So we have that if sin theta is equals to cos 90 minus this, so we now have that sin theta is cos 90 minus theta, this theta will now be equals to, we now equate it, if sin theta is this, so we can now use this in place of this, we substitute, is now equals to cos 35 degree. So at this point we have cos can cancel cos. I don't advise my students to cancel because it makes your work rough. So this, we cancel this. We are now going to bring 90 minus theta and 35. This will give us 90 minus theta is equals to 35 degree, 90 degree. So at this point we collect like terms. This is a constant term, this is a constant term, this is an unknown term. It has to cross over. So and this one has to come. So we now have 90 degree minus 35 degree is equals to, this one is minus, once it's crossed, you change to plus, we have theta. So 90 minus 35, 90 minus 35 will give me 55. So 55 degree is equals to theta. You can as well say that theta is equals to 55 degree. So that is for the first one. Okay, let's quickly solve the second one. Let's quickly solve the second one. Okay, we have the second one. We're going to have second one. We have sin B, sin alpha is equals to cos 3 alpha. So remember that is either we make this one to be the same. So remember that sin theta is equals to cos 90 minus this. So we can use this thing to replace this. So we now have that cos 90 minus alpha will now be cos 3 alpha. So at this point we have cos can cancel cos. So from there we now have 90 minus alpha is equals to 3 alpha. We collect like terms. This alpha will cross over to meet this colleague. We now have that 90 is equals to 3 alpha plus alpha. So 90 will now be equals to 3 alpha plus alpha will give us 4 alpha. For us to get the value of alpha, we divide both sides by the equations of it, which is 4. We divide by 4, we divide by 4. So 90 divided by 4 will give us so that means alpha will now be 22.4 degree. So that is for alpha. Okay, let's quickly solve this one. After this third one now, we are going to stop. So now let's go. Third one says cos 2 theta is equals to sin 3 theta. Okay. See what we are going to do? At this point, we resolve this one first. So remember, cos theta is equals to sin 90 minus theta, right? But here we now have cos 2 theta. It will now be equals to sin 90 minus 2 theta. So if cos 2 theta is equals to sin 90 minus 2 theta, we can now equate it to this. So we now have that sin 90 minus 2 theta will now give us a sin 3 theta. So at this point we have sin can cancel sine. So we are now going to have, if sine should cancel sine, we'll now be having 90 minus 2 theta is now equals to 3 theta. Collect like terms. This one is minus here. Once it's crossed, we change to plus. We have 90 is equals to 3 theta plus 2 theta. So 90 is equals to 2 plus 3 will give us 5 theta. We divide both sides by the quotient of theta, which is 5, divided by 5. So this will now be 90 divided by 5. It's going to give us will give us 18. So theta is equals to 18 degree. So at this point, we have drawn the curtain. Thank you so much for your maximum cooperation. So definitely, I'm going to give you guys exercise in PDF format. So maths is very easy if you bring out time, you read, you solve more questions, you go through exercise. So definitely you're going to understand it. Yeah, maths is fun when you bring out your time to read. So I'll give you guys more questions on trigonometry and linear equations, algebraic expressions to solve. Thank you so much. God bless you. I really appreciate it.